Hello, everyone. Today we're going to start by talking about something called exponential notation. So let's say we had repeated multiplication like 2 times 2 times 2. We could write this as 2 to the third power, where 2 is what we call the base, and 3 is what we call the exponent. So an exponent is a little floating number uh, off to the top right of a base. And the exponent tells us how many factors of the base there are. We had 2 times 2 times 2, 1, 2, 3 factors of 2. So 2, the factor that's repeated, is the base. 3, the number of factors we have, is the exponent. And we would evaluate this from left to right because it's all multiplication. 2 times 2 is 4 times 2 is 8. Let's evaluate some other things written in exponential notation. Feel free to pause and work along once you catch on to what we're doing. 3 squared, that's 2 factors of 3. And 3 times 3 is 9. So 3 to the second power is 9. When we have a second power, I might have already said it because it'll come natural to you eventually. The second power we referred to as squared. Squared means a number times itself. 5 to the third power. That's 3 factors of 5 because 3 is the exponent. 5 times 5 is 25. 25 times 5 is 125. So 5 to the third power is 125. And when we have a third power, we refer to that as cubed. So we could say 5 cubed is 125, or in the example we started with, 2 cubed is 8. We don't have any special names for fourth power and on, so this would only be able to be read 2 to the fourth power, but that's 1, 2, 3, 4 factors of 2. Left to right, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So again, 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16. 2 to the fourth power is 16. Couple more. Fractions, very important. We're going to keep coming back to fractions. Fractions make up a large portion of this first part of the material because it's important that we're comfortable with them. We know how they work. We know how to add, subtract, multiply, divide them. First off, 7 to the first power. The exponent 1 tells us we just have a single factor of 7. So anything to the first power is itself. 7 to the first is 7. Now on to this fraction. 3/7 squared, 3/7 to the second power. That's 2 factors of 3/7. We have 3/7 times 3/7. Multiplying fractions, nothing cancels. Multiply across the top, 3 times 3 is 9. Multiply across the bottom, 7 times 7 is 49. 9/49. So as we've been evaluating, I said it's all multiplication. We can just go from left to right. But what if we have a mix of signs? Stepping away from exponential notation, just to this problem here, 2 plus 3 times 7. Well, it depends on what you do first, the answer you get. If we go from left to right, 2 plus 3 is 5. 5 times 7 is 35. I put that in red. That should be a red flag. What if we multiplied first? What if this was 2 plus 3 times 7? Well, if we multiply first, 3 times 7 is 21. 2 plus 21 is 23. I put that one in green. Which is the right answer, 35 or 23? And it turns out the answer is actually 23. Why does it turn out that the answer is 23? It's because of something called order of operations. Order of operations tells us that first we would work inside grouping symbols, parentheses, brackets, things like that. Then we would deal with exponents. Then we multiply and divide from left to right as we come to it, which will leave only addition and subtraction, and then we do the addition and subtraction from left to right as we come to it. Parentheses, grouping symbols, exponents, multiplication and division, addition and subtraction. PEMDAS. People usually remember PEMDAS as please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally will help you remember PEMDAS. Parentheses, exponents, multiplication and division, addition and subtraction. And notice I keep grouping multiplication and division together. I keep grouping addition and subtraction together. Order of operations is a 4-step process. Multiplication and division are in a step together from left to right as you come to it. Addition and subtraction are in a step together, left to right as you come to it. This does not mean do multiplication first, then division. This does not mean do addition first, then subtraction. Once again, the multiplication and division is left to right as you come to it. Division might come before multiplication if it's first. Addition and subtraction, left to right as you come to it. Subtraction might come first. Let's do a bunch of problems now involving the order of operations. And actually, let me put PEMDAS up in the corner so we're always aware. I always write it like this, showing what the 4 steps are, showing that multiplication and division is left to right, addition and subtraction is left to right. Let's take a look at 6 divided by 3 plus 5 squared. Order of operations says first we work inside parentheses and grouping symbols. We don't have any of those. So we move on. Order of operations says next we do E. We do exponents. Everything else stays the same. 5 squared is 25. Next, we look for any multiplication and division that we have from left to right as we come to it. And this very first thing is a division problem. 6 divided by 3. That's 2. Leave the rest alone. Finally, we have 2 plus 25. Our answer is 27. Let's look at another. 20 divided by 5 times 4. Now, I feel like I'm beating a dead horse at this point. Multiplication and division, left to right, as you come to it. We're on that step already because there's no parentheses, there's no exponents. It's super important that that left to right, as you come to it, is how you do the problem. First, we have this division. 20 divided by 5 is 4. Leave the rest alone. Now we have 4 times 4. The correct answer is 16. If you didn't follow order of operations, or I should say, if you misunderstand the order of operations, if you look at PEMDAS and go, M comes before D, multiplication comes before division, you would do 5 times 4 first, which would give you 20. Then 20 divided by 20 would be 1. That is not correct. It does not give you the same answer. Order of operations is all about making sure you can consistently get the same answer as everybody else doing the problem. There should be no situation where you look at this and you get an answer of 1. Unless it's written like this. I put parentheses around the 5 plus 4, or sorry, the 5 times 4. And now when I follow order of operations, parentheses first. Inside the parentheses, we have 5 times 4. 20 divided by 20 is 1. So written like this with parentheses around the 5 times 4, that's the only way that these numbers work and give you 1. So order of operations is important to follow, and understanding that multiplication and division is in 1 step left to right. Addition and subtraction is in 1 step left to right. It's not multiplication first. It's not addition first. That won't always be the case. Okay, let's do some more. Two times in parentheses 12 plus 3, all over the absolute value of negative 15. When we have it looking like a fraction, when we have a division bar, we treat the top as one problem, we treat the bottom as one problem, and once they're both simplified as far as they can go, we divide at the end. Or if it's not divisible, we reduce the fraction form that we have. So what do we do on top? Parentheses first. Inside the parentheses, 2 plus 3 is 15. All that's left on top is 2 times 15. That's 30. On the bottom, we just have the absolute value of negative 15. Since that's all there is to do, there isn't any confusion about what comes first on the bottom. But if there were other things happening down there, absolute value is a grouping symbol. So it would fall under parentheses. We would work inside the absolute value in a first step. The absolute value of negative 15 is positive 15. Nothing else to do to that, so let's carry it over to here. They're both simplified top and bottom as far as they can go. So we divide 30 divided by 15 is 2. And again, had that not been able to divide evenly, we would just reduce the fraction. Next up, 3 times 4 squared. Be very careful. Parentheses, no grouping symbols, nothing to do there. Exponents. We have to do the exponent next. What is the base? The base is just what the exponent touches. So it's just a base of 4. Leave the rest alone. So we have 3 times 4 squared. That's 3 times 4 times 4. This is not 3 times 4 equals 12 and then 12 squared. Let's finish this off. It's all multiplication, so left to right as we come to it. 3 times 4 is 12. 12 times 4 is 48. If the problem intends us to do the 3 times 4 first, it would be in parentheses. So see the difference. In this first one, the exponent of 2 is only attached to the 4. So all we'd square is the 4. Here, the parentheses group the 3 times 4 together. We work in parentheses first. 3 times 4 is 12. So we have 12 squared, which means 12 times 12, which means 144. So 2 very different answers. The only thing that's changed in the problem is parentheses are in one, but not the other. Fractions are important. Three halves times 1/2 minus 1/2. Order of operations says parentheses, we have none. Exponents, we have none. Okay, so now let's multiply and divide from left to right as we come to it. This first problem is multiplication. 3 halves times 1/2. That's 3/4. So we have 3/4 minus 1/2. 3 times 1 is 3. 2 times 2 is 4. Then we have 3/4 minus 1/2. In order to do that, we need a common denominator. That common denominator is going to be 4. 1/2 written with a denominator of 4 is 2/4. 3/4 minus 2/4 gives us a final answer of 1/4. So order of operations, important. If instead of multiplying first, you mistakenly subtracted first, you would do 1/2 minus 1/2 is 0. Anything times 0 is 0. You would get an answer of 0, which would be wrong. Let's look at another crazy one. Three plus the absolute value of 4 minus 3 plus 2 squared all over 6 minus 3. We have a fraction bar. Top and bottom, 2 separate problems until the end. And on the bottom, all we have is 6 minus 3. Let's just go ahead and make that 3 now. On top, first comes parentheses, but remember parentheses means any grouping symbol. We have a grouping symbol. We have this absolute value. So we work inside the absolute value first. 3 plus the absolute value of 1 plus 2 squared. What is the absolute value of 1? It's just 1 plus 2 squared. No more grouping symbols. Exponents. We've got one. 2 squared is 2 times 2, that's 4. 3 plus, all that's left on the top is addition. So left to right as we come to it. 3 plus 1 is 4. All that's left on top now is 4 plus 4, which is 8. Can we do 8 divided by 3? No. So we leave it in fraction form. It does not reduce. You want to try one of these crazy ones? If you feel like a challenge, go ahead and pause this next one. I'm going to go ahead and get started with it. Top and bottom, 2 separate problems. On top, we have no parentheses. Exponent, 6 squared is 6 times 6, that's 36. 36 minus 5 is 31. So that's all we can do on top. Let's start working in the bottom. Parentheses, grouping symbols. We have the absolute value. 3 plus the absolute value of 6 minus 5. 6 minus 5 is 1. Times 8. The absolute value of 1 is 1. 3 plus 1 times 8. What comes first, the addition or the multiplication? PEMDAS says multiplication comes before addition. So leave the 3 plus alone. 1 times 8 is 8. And then 3 plus 8 is 11. 31 over 11 is our answer. Three bracket 4 plus 2 parenthesis 10 minus 1 close parenthesis close bracket. In this problem, we have two sets of grouping symbols. We've got these parentheses. We've got these brackets. Those aren't absolute value signs. These are brackets, square parentheses. Where do we start? Parentheses grouping symbols comes first. We're always going to start with the innermost set of grouping symbols first. Why? Let's say we start with the other ones first. We technically are. Why? Because inside this grouping symbol, what would we do first? Grouping symbol. So we always end up first at the innermost grouping symbol. Leave everything else alone. 3 square bracket 4 plus 2 parentheses bracket. Inside the parentheses, 10 minus 1 is what we do first. 10 minus 1 is 9. Now there's nothing else to do inside these parentheses. This now means 2 times 9. Whenever we have a number right up against parentheses, it means multiplication. Now, these are the only grouping symbols that are left, these brackets. Working inside the brackets, we have to take care of 4 plus 2 times 9. This is not 6 times 9. Order of operations says we do multiplication first. 4 plus 2 times 9 is 18. We have the 3 right up against this bracket. That, just like the 2 times 9, the parentheses meant times, the bracket means times. There's no difference between square parentheses and regular parentheses. They're just different shapes, so you don't get confused as to which starting one goes with which ending. So this is 3 times 4 plus 18 is 22. 3 times 22 is 66. Let's do one more like that. Feel free to try. Four, then in brackets, 25 minus 3, then in parentheses, 5 plus 3. Close the parentheses, close the bracket. Innermost grouping symbol first. 5 plus 3 is 8. Inside the brackets, multiplication first. 25 minus 24 is what we're left with, which we still do because we're working inside the parentheses, the grouping symbols. 25 minus 24 is 1. 4 times 1 is 4. Two more. Fraction bar means we have two problems. On the top, we would multiply first, leave the 8 plus. 2 times 3 is 6. 8 plus 6 is 14. On the bottom, exponent first. 2 squared is 4. 4 minus 1 is 3. We can't reduce 14 thirds. 14 thirds is the answer. Feel free to try. I'm going to get started with it. On the bottom, 5 squared is 25, exponent first. 25 minus 3 is 22. On top, division first. 36 divided by 9 is 4. 4 plus 5 is 9. 9 over 22. Okay, let's move on from order of operations. Previously, I mentioned variables. Variables are letters that stand for numbers. Previously, we've used, when we were talking about fractions, A, B, C, D, but you'll also see N, X, Y, Z. Any letter can be a variable. And variables just represent numbers. When we have a collection of numbers, mathematical symbols, and variables, we have what's called an algebraic expression. So things like 2y or 3x plus 1 or 3 over x plus y over z. These are algebraic expressions. They're mixtures of, even just the number 6 is an algebraic expression. We have a mix of numbers, variables, and signs like plus or minus, times or divided. One thing we can do with expressions is if we are given a value for the variable, we can plug that number into the expression and evaluate it. Evaluate for this next group, when x equals 3, and y equals 2. Evaluate means we have some expression like 2x minus y, and we want to plug in 3 for x. We want to plug in 2 for y. What does this have to do with what we're talking about today? Well, once we plug the values in, we have to follow order of operations to continue to evaluate to an answer. Multiplication first, 2 times 3 is 6, minus 2, 6 minus 2 is 4. We just evaluated 2x minus y when x equals 3 and y equals 2 and got an answer of 4. Same values. Three x over 2y. Feel free to try these. We plug in 3 for x. We plug in 2 for y. 3 times 3 is 9. 2 times 2 is 4. We get 9/4. X over y plus y over 2. 3 is x. 2 is y. 2 is y. 3 halves plus 2 halves is 5 halves. X squared minus y squared. When we plug in values that are squared or cubed or to any power, use parentheses. Because whatever we're plugging in its entirety is the base. Here, x squared, the base is x. So the base is however much information we have for x, all of it. In this case, it's only 3. And for y, we only have 2. 3 squared is 9. 2 squared is 4. 9 minus 4 is 5. So that's evaluating expressions. We evaluate expressions. We solve equations. What's the difference between expressions and equations? Expressions, no equal sign. Equations, yes equal sign. If there is an equal sign, what you have is an equation. You cannot evaluate an equation. You can solve it. You can come up with solutions. Let's say we have 3 plus x equals 5. 3 plus what equals 5? 2. 2 is a solution because it makes the statement true. 3 plus 2 equals 5, and 5 equals 5. Is -1 a solution? Well, let's plug it in and check. I don't want to use negative numbers yet. That's next time. Let's go ahead and ask, is x equals 1 a solution? Plug it in. 3 plus 1 equals 5. That gives us 4 equals 5. No, because it's not true. 4 does not equal 5, so x equals 1 is not a solution. Question, is 2 a solution of 3x plus 10 equals 8x? I don't know. How can we check? Plug it in. If we get a true statement, then yes, it is a solution. If we don't get a true statement, then it is not a solution. 3 times 2 is 6. 6 plus 10 is 16. We end up with the true statement, 16 equals 16. So yes, 2 is a solution for this equation. One more. Feel free to try this. Is 4 a solution of 9x minus 6 equals 7x? Plug it in, plug it in. Just like the old Glade commercials that, depending on your age, you may or may not remember. Plugging in 4 for x. 9 times 4 is 36. 7 times 4 is 28. 36 minus 6 is 30. We get the statement 30 equals 28. No, this is not true. This is false. So 4 is not a solution of 9x minus 6 equals 7x. Okay, I'd like to share this with you. When we're translating phrases from English to math, there are certain words that you want to watch out for, which means certain things. When we see sum, plus, added to, more than, increased by, or total, these are words that indicate that we're using addition. When we see words like difference, minus, subtracted from, less than, decreased by, or less, these are words that indicate that we are using subtraction. Product, times, multiply, twice, of, These are words that indicate that we're using multiplication. Division words are words like quotient, divide, into, ratio, divided by. And words that mean that we have our equal sign are words like equals, gives, is, was, should be, yields, amounts to, represents, or simply is the same as. All of those mean equal sign. For our next examples, we're going to write these English phrases as algebraic expressions. We're going to use x, the variable x, to represent, quote unquote, a number. So in example A, we have 5 decreased by a number. It's 5. Decreased by, well, that's one of our subtraction words. A number, we were told to use x. So 5 minus x is 5 decreased by a number. 5 minus x. In part B, the phrase the quotient of such and such and such and such, that's represented with the division sign. Order is important when we're using division. Order is important when we're using subtraction. A wasn't x minus 5 because that would be a number decreased by 5. Order matters. And the order is given in the phrase for this division problem. It's the quotient of a number and 12. That's the order. A number, x, divided by 12. 12. X divided by 12 is the quotient of a number and 12. We can also write division using a fraction bar. So x divided by 12 could also be x over 12. Remember, fraction bars are just division. You want to try some? Go ahead and try these. Or just follow along with me. Here I go. The product of 5 and a number is 5 times x, 5x. Product means multiplication. A number added to 7. Now, order doesn't matter with addition. We're going to see that in a couple sessions from now. But let's do this literally. If a number is added to 7, that means we're starting with 7 and we're adding the number. 7 plus x. Would x plus 7 be wrong? No. But only because addition, order doesn't matter. Subtraction and division, the order definitely matters. So in C, we have a number divided by 11.2. We are starting with that number. We are dividing it by 11.2. X divided by 11.2. Twice a number plus 1. Twice a number means 2 times that number, 2x, and then plus 1, 2x plus 1. Now, these examples have all been expressions because none of them have had words that indicated we have an equal sign. That's going to change now. The quotient of 15 and a number is 4. Quotient is division. The quotient of blank and blank tells us the order. 15 and a number. 15 divided by that number. 15 divided by x is 4, equals 4. Eventually, we're going to be able to solve this for x. Part B, 1 less than twice a number is 99. 1 less than twice a number means we are starting with twice a number. We are starting with 2x. 1 less than that means we are subtracting 1. 2x minus 1 is 99. 2x minus 1 equals 99. Okay, that's it for today.